All right. I think let's start. Yeah, and Kia koto. My name is Wolfgang Hayek. I'm the research software engineer at NIVA, and I'm the host for this session here in the morning. So we have two speakers in this session. Unfortunately, we lost one of our speakers, so we'll have a little break in the middle of the session, and then we'll break for lunch. So our first speaker this morning is Dr. Michael Coe from the University of Canterbury. Michael is a postdoctoral fellow in chemical and process engineering under the Biomolecular Interaction Center and an assistant e-research consultant at the University of Canterbury. And so I'll hand straight over to Michael. And if you have any questions for Michael, please enter them into the Q&A box. Michael, over to you.
Hi, everyone. I'm Michael Coe, and I'm here to talk about the need for a privacy-first transcription application. So this is a little side project I've done as a e-research consultant. First, I'd like to show off my team who have been very supportive during this process. So there's me. Again, I hold a postdoctoral fellow position in the Biomolecular Interaction Center. My colleague, Paul Benden, who is also a part-time researcher in the Department of Forestry here at University of Canterbury, Francois, who is an e-research consultant, and our leader, Jamie Hart. So how many people have read the terms and conditions for software packages? This is terms and conditions for a package called Read AI, which is a popular transcription service. And you can see that you grant Read AI a non-exclusive, royalty-free, worldwide, fully paid license, and they will not pay you for any of your data. And then you also waive any moral rights or other rights to your data by signing up to their service. So this is kind of a typical terms of service for transcription application. We can see some problems with this. So the motivation for this project is, like I've said, many companies have terms that you give rights to all the data that you upload to their servers, which is all audio and video. Transcription services often will attach themselves to meetings without notifying any users. So if you give them the rights for that, we've been having problems with that in the past. These companies are often located overseas, and so you're transferring your data offshore, which makes it subject to foreign laws, especially with the United States, Australia, and all other countries. And we also run into issues when you're transcribing sensitive interviews or indigenous data. So, for example, maybe you're transcribing interviews for domestic abuse survivors. Obviously, you don't want that data to get out. It's very sensitive. So this brought us to the need for a local privacy-focused way to transcribe data for researchers. And then briefly, I'm not going to go over Maori data sovereignty because that's sort of a whole presentation in and of itself. But the gist of it is that they would like to repatriate the data back to the hapu or iwi. I'm sorry if I butchered those words, but I'm not from here. So, right. So we'll give this is a demo. So we'll have a little demo. It's currently a public repo. So you have access to all the code with the current transcription app. And just here is the sort of architecture or an overview of what it does. So we spawn a session. Again, I'm using Streamlit, which we saw yesterday with Maxine. I have just learned about RShiny, so any questions for that, I'll taking a look. But no, I didn't know about it beforehand. So the general gist of it is we upload a file. We have to initialize the transcription model. If it's not present, we download it. We transcribe the audio. The transcription is saved to a temp file using the Python temp file library. And then we do some operations to convert the transcription to whatever format we want, which I'll show you in a minute. And then after the transcription is downloaded, we delete the transcription. So we always delete the audio and the transcription with every session. So nothing is saved on our servers, and this is all run locally on our local research compute cluster here at the University of Canterbury. So here's the front end of the transcription. This is actually the development version. The only difference between this version and the live version is that there's no speaker diarization, which I'll go into in a minute. But essentially, the idea behind this is that we wanted it as simple as possible for our users. Just anecdotally, we have a restaurant here called the Afghan restaurant, and the guy serves only one meal. There's no menu. He just serves the same thing every day, and he always has a line out the door. So that just tells you people kind of want things simple. Our users are not technical, so they need something simple that'll just get the job done. And so that was the idea behind, behind using Streamlit and also behind the simple interface here. So I've already transcribed an audio here. So you just drag and drop, choose some options, hit transcribe. And then once your transcription is complete, this is just a video I did for my postdoctoral research. You get the transcription out. You can change formats to whatever you really want. We're looking at implementing more formats, and then you can download the transcript here. I've already downloaded it, and I've also downloaded the newest development version that we're implementing speaker diarization, which I'll show you in a minute. But essentially, you get time codes and then sentences. I mean, everyone's seen the transcription. For speaker diarization, you get this kind of mess. But what's interesting here is that, so this is the sentence here, but you get word by word, start and stop time codes. So each word has its own time code associated with it. And I'll go into why we want that in a minute. So that's a brief overview of what the transcription application is, and we'll go back here. So this relates to sort of the future work we're implementing here. So I'm working with Robert Fromont of the New Zealand Institute of Language, Brain and Behavior. And we're trying to implement an annotation graph class. So what an annotation graph is it has each word with its own timestamp, start and end timestamp. And then we also have speaker diarization where we might have multiple speakers and we want to label which speaker said what. And then this is quite important for linguistics and for interviews and whatnot. So the way I'm going to go about this is currently I'm implementing WhisperX, but the package hasn't really been maintained for maybe a year or so. So I'm going with the PyAnnotate package, which takes a little more setup, but it's more actively maintained. For the word alignment, so I'm going to create a new AG class. I'm going to write converters for popular linguistic formats like Elon, TextGrid. And the benefit of using the AG graph is that it's sort of agnostic to whatever your format you're using. And then I'm going to look at making the app a front end, because right now we have maybe 7 or 10 users, but it's actually gaining popularity every week. I've been keeping track. And so if we still have that growth, we'll need a better way to schedule the inference operations. So we're using Slurm as a front end. Sorry, we're going to have the front end be sort of hooked into a Slurm scheduler, and the Slurm scheduler will schedule the GPU operations, and then we'll sort of send the transcript to the researcher when it's ready. And then looking at implementations like insanely fast whisper, or other ways we can increase performance. Actually, insanely fast whisper is really just a pipeline that does batching on the audio. So it takes chunks of the audio and does the inference on those chunks in parallel. And that's why it's so much faster. So we'll look at doing that. We'll also look at models that allow for Maori transcription. So right now it's sort of English and maybe some foreign languages, but not really Maori. There is a commercial model available, but it's on subscription base. So there's no open source right now. And we're looking to maybe train our own. So some lessons learned from doing this project, and obviously it's 2 months old. So, but data is valuable to companies. So always read the terms and conditions. And when you're working with open source packages, you should make sure you fulfill the license requirements. So this is some BSD and GPL are licenses for open source packages. Yeah, so that was pretty short and sweet, eh?
Okay, thanks very much, Michael. Great presentation. So just a reminder, please post your questions in the Q&A box. And we have a first question from Alex. How do you measure the accuracy of your transcription app?
Yeah, that's a good point. Generally, there's a lot of metrics out there that are pretty arbitrary, in my opinion, but we're looking at the word error rate right now. So if you look at these underlying models, sort of like the Whisper model, or well, this does use the Whisper model. They have a word error rate, which is like a percentage that the model gets the word correct, and that's sort of what we're looking at.
Thanks. And so how do you go about including new languages? So you said before that you're looking into including Maori language. And so how would you go about that? So I guess you probably have to provide speech samples. And is there a training facility in the app itself, or do you have to go really all the way down to the model to train it directly?
Right. So there are ways that you can train your own models. And I've done that before, so we can do that. We do have facilities here where we can train machine learning models, and so the idea we would need a lot of audio and and transcriptions of that audio to train the model correctly. Yeah.
Okay, a question from Maxime. Are you planning to add, if it's not already there, a way to play back the recording with highlighting words to double check?
Maybe in the future, but generally, like the way researchers use this is they'll get the transcription and then they'll put it into something called TextGrid or Elon, which has this sort of playback and annotation features. So with anything with machine learning, you have to really check over it afterwards anyway. So that's sort of how they do it. Yes.
Okay, so Nick comments that Whisper does support Maori language.
It does, but the word error rate is quite a bit lower than English. So I have done a few Maori transcriptions, but I think it's not as good as just regular English.
So how close do you have to be to sort of the canonical pronunciation of words? I guess that these tools sometimes struggle a little bit with accents, right? So, I have a quite solid German accent. So if I try to speak a different language, like say English, for example, some tools might be struggling a little bit with that. Do you have experience with that?
Yeah. So I've been testing on videos from Quakecore studies. So it's people interviewed about their experience with the earthquakes here in Christchurch, and you can see like when I do transcriptions of my own voice, because it's a very neutral American accent, it does pretty well, but sometimes it messes up the really thick Kiwi accents. I don't know if there's a way to get around that. I currently have a researcher asking about Afrikaans accent, which is so we're gonna tackle that problem, but I think it probably requires some fine tuning of the model.
Mm-hmm. We have a question from Wes. Have you decided on a method to communicate with a Slurm scheduler?
No, not yet. I can't. I'm not at liberty to say what about the future, but yes, not yet. Mm-hmm. That is on my list of to do, but like I said, this is sort of a side project. It's not really. This is just something I wanted to do for the researcher community, and that I had my bosses sign off on. So.
And so, how do you? So, can you integrate into apps like video conference services or something like that, or does it always run on its own?
Right now, it's only running on its own. That is something that I have thought about doing, but we're only like 2 months in, so we're really it's still really under development. Yeah.
So what kind of resource footprint do you need for a single session? Is it running on a single GPU, or do you need more than
Yeah. So right now it's running on a Tesla T4, and it uses about 4 gigabytes of VRAM. I do have proper garbage collection, and I free the cache after every transcription. And I also have a check there. If you don't have enough VRAM to do a transcription, it'll offload it to the CPUs instead on the VM that we have. But yeah, so it uses about 4 gigabytes of VRAM per transcription, depending on your model.
I mean, it sounds like something you could almost do at home, right? So if you
I've done it at home, yeah.
Yeah, okay, right. Okay, do we have any more questions? So please type them into the Q&A box. Also, one more question from me. So do you have an API in this? So if I wanted to write my own app, something fancy about, I don't know, a mobile app or so that lets me record things on the go, can I use an API there to record things?
No, there's no API, but it just uses pure Python, so you can just hook in whatever you want, really. Mm-hmm.
Okay, I see no more questions coming in right now. So yeah, thanks, Michael, again. Fascinating demo.
Thank you.
And now we are going into a little break. So for those who have just joined, we lost our middle presentation in this session, unfortunately. So we'll go for a break for the next 20 minutes, and we will restart the session at 11:40 a.m. Kia ora, and welcome back to the continuation of the session. I'm Wolfgang Hayek, in case you joined us just now, and the session chair for this session. And I hope you all enjoyed a few rays of sunshine while you were waiting for our final presentation for this session. So I'd like to introduce Jun Ha. He's a product manager at NZRSE, and he's working on flexible HPC and the Research Developer Cloud. And his talk will be enabling innovation and collaboration with NZRSE's Research Developer Cloud. Okay, so please take it away, Jun.
Awesome. Thank you. Thank you, Wolfgang. Kia ora koutou. My name is Jun, product manager at NZRSE. Today I'll be talking about NZRSE's Research Developer Cloud. I gave a same talk last year as we launched the Research Developer Cloud, but we'll give you some updates. So in this talk, I'll go through what is Research Developer Cloud and updates since last year, and we'll look into some example scenarios. We've had some early tenants using the system, as well as ourselves building stuff in the cloud. And I'll talk about what's next and what's in it for you. So what is Research Developer Cloud? So it's an infrastructure as a service. It enables you to build custom research tools, deploy your own software, empowering research software engineers. So infrastructure as a service, this differs to NZRSE's traditional HPC in the sense that NZRSE HPC is more of a queue-based. It's a specialized kit. We compare it with sort of shared wood-fired oven, whereas the cloud offering that we have is then giving you access to a small but whole kitchen where you can experiment and you want interfere with other people's kitchen. So it gives you opportunity to deploy more of an interactive or long-running solutions. So the cloud service offering, it doesn't differ too much from other public clouds such as AWS or Catalyst. So we started with basic cloud services such as compute, images, storage, network, and all of it available through API. But we aim to differ from all the public cloud offerings through focusing on collaboration and building the shared knowledge and trying to empower the community. And also we are constantly learning as much from you as we are sharing the knowledge. So we are really focused on good developer experience and honing in on that shared knowledge. Also, there's a benefit of adjacency to existing NZRSE services. So if there's a huge jobs to be processed on the HPC, it will be easier to pass on data to NZRSE's HPC. So we very much for infrastructure as code approach. So instead of launching a VM and just installing and deploying stuff, infrastructure as code enables us to use technologies like Terraform and Ansible, and it's akin to writing a recipe that's repeatable, transparent, and it makes collaboration a lot easier. So I will skip some of the slides. I do have a lot of content, so but we are very much promoting the DevOps workflow. We have Kahu joining us last year as a DevOps specialist, and we had Andre joining very recently in the same role. So we are growing that in-house knowledge of DevOps practices and tooling and so on, as well as a security approach that we are improving across all steps of DevOps. So as for the updates since last year, we have had some internal system updates. So we now support latest Rocky OS and various Ubuntu images and various performance tuning. So the system is a lot more stable, and we have now gone live with object storage. But real interesting part that I will be sharing is our experience that we gained from our early tenants. So we collaborated with these 3 early tenants. I will go through more details and a lot more detail on our internal usage. So one of the first one that NZRSE's been working on even before the Research Developer Cloud is AGDR, Aotearoa Genomic Data Repository. This is our collaboration with Genomics Aotearoa for building a long-term data repository of genome sequencing data for taonga species. So the key here is around kaitiakitanga and FAIR principles and having the data safe and accessed with a proper approval process and everything using various open source technologies such as Gen3, and we have made a good relationship with University of Chicago, who developed Gen3 as well. And here's a screenshot of the data repository at the moment, and our data set's growing gradually. Nice to see. And one of the early tenants that we that started using the Research Developer Cloud end of last year was the Oakman project. They are a group from Auckland Bioengineering Institute, and they had they were developing a mobile app for taking videos of children to detect early detection of neurological disorders, and we needed a backend server for hosting the video data. So this is a good example of utilizing the cloud for a scenario that's more of a backend part of the pipeline that may feed into HPC use. And another example is Christoph Muller's group from GNS. They were looking at deploying Kubeflow, which is Kubernetes-based AI workflow tool. And they have successfully deployed a prototype. And I think that one of the key use case was to enable a researcher, Emily Lane from NIWA, to be able to access the applications. And another example here is our collaboration with Malaki Whenua Landcare Research. They had a couple of projects. One is the LUMAS one, is the land use management support system. And again, it's for setting up a pipeline for building models that feeds into LUMAS system. And it was originally Alex Herzig's workstation that enabled that process, and Malaki Whenua wanted more of a more accessibility to wider group. So this cloud use case was looking at possibility there. Here's a screenshot of that. And another project that started mid this year is the DeepSec project, which is around remote sensing, machine learning, and the cloud use cases here is, again, deploying the pipeline into the cloud and making it more accessible by wider group within the organization. And some of the upcoming challenges is passing some of the work that machine learning workload into NZRSE HPC, which is one of the Manakivenwa's existing usage of NZRSE HPC. So maybe connecting those two, it's not something that's been done yet, but probably something that will be worked on. So I'll go into a bit more details on our internal projects. So as we are collaborating with various partners and tenants, here's a sort of a very abstract diagram of technologies being used and where some of the technologies knowledge is being shared and connected. And the idea is for us to keep working with various growing groups and build that knowledge and enrich the community as a whole. So one of the things that we started working on mid end last year was NZRSE's training environment. So we've been delivering trainings through NZRSE HPC and our Jupyter Hub, but we wanted something more standalone so that people outside of NZRSE, our partners, can deploy an environment and run training as well. So we started off as applying those infrastructure as code practice and learning Ansible and Terraform ourselves, building that experience, and we ended up delivering over 20 training events using the new training environment. So the technology that we use here is open on demand with Kubernetes backend and key clock for identity. So we have a GitHub repo. So I'll share all the relevant links at the end, and there's a link shared by Donna on the Q&A as well. So you can check the slides later on. We have a GitHub repo where you could make updates and trigger a pipeline to deploy an environment so that you can run a training and then take down the environment afterwards, and then you can essentially launch like multiple instances of these wherever cloud that you have access to. So it's not just limited to Research Developer Cloud. So here's a little screenshot of our open on demand based training environment. It's not really styled or anything. The other project is that we are using it to prototype a lot of NZRSE migration efforts. So we are in the process of building our next HPC, and we are using the cloud to deploy the new instances of all the services surrounding the supporting the HPC. So things like Slurm and Keycloak for identity management, Globus, and all of that stuff. And one of the things that we are also doing is deploying the next iteration of Jupyter Hub environment for interactive application. We are calling it NZRSE On Demand. It's using open on demand technology with NFS drive, free IPA as the Linux identity key clock for web identity. And we are using tools like Terraform and Ansible and GitLab pipelines to make things repeatable and all the good DevOps practices applied. So here's a screenshot of NZRSE On Demand. We are still developing, and once you select Jupyter Lab, you can click on it and launch the instance, go in there and do some interactive notebooks with Python and things like that. And I will skip the detailed architecture, but this is our GitLab repo showing our pipeline with the deployment process. So it shows all the history of the pipelines that's triggered by various team members working on it. And also you can see when the dev environment was last updated, which was 4 weeks ago, and the test environment has recently been updated 4 days ago, and so on. So we can see the status of various deployment status of our development. So in terms of what's next, we will continue improving the service offerings, and we do have a GPU access, but only at a whole node level, so which isn't too practical, but we're looking at vGPUs that you can access small part of the GPUs as well, and improvements on access and secret management and things like that. Also, we will continue to build, learn from all of these projects and build blueprints and patterns. Here are some examples. I have some links at the back on Kubernetes and our training environment. So we will continue to build knowledge and share the repositories and things like that. So we see we want to contribute to the community in a way so that RSEs can come in and collaborate with us, and wherever the gaps might be, whether DevOps practices or certain specific programming skills or whatever it might be, we would collaborate and try to aim for solutions that's more widely accessible eventually, and using the tools that enables that transparency and sharing. And here's a screenshot of our support site. And we invite you to apply for access, especially if you are developing complex solutions that support custom workflows, and seeking like local cloud computing platforms, and really interested in partnering with NZRSE to apply DevOps approach. So you can read more about the Research Developer Cloud at the link below, and please feel free to reach out at the support email there. And here are some people involved in some of the key early partners, and here are a bunch of useful links that I touched upon. And you can also, I did that just before the start of the presentation. I added the QR code if you want to scan that. And thank you.
Thanks, John. Great presentation. And we already have a few questions rolling in. We still have a few minutes left in the session, so please feel free to write more questions in the Q&A box. Okay, so first question from Alex. Thanks, June. Do you expect the research community to move from shared scheduler-based computing to the research dev cloud in the future? Or do you see traditional Slurm-based research computing to coexist with the research developer cloud?
I think it's definitely gonna coexist. We're not building this to replace it, but more to augment HPC. So we see a lot of interest around running, sort of even integrating more interactive interface with traditional HPC type workload. So there might be some gateway that enables research group to access web-based interface and submit machine learning workflows into HPC and things like that.
Mm-hmm. And Maxime asks, for RSEs without admin sys background, how easy is it to learn Terraform and Ansible? Would you have some recommendation on how to learn enough of the DevOps knowledge to get work done without having to become a cloud expert?
I do have a software development background, but I didn't know Terraform and Ansible before. And by looking at some examples, I was able to pick up some basics, but I think it definitely takes it's just like any other programming language, it can get really deep as well. So I think it's not too, I wouldn't say it's any more difficult than picking up other programming languages, but perhaps someone of more expertise could answer. I saw Chris Scott in the attendance. He might be able to answer on the questions section. Yeah.
And we have a question from Senso. In the notebooks you presented in one of the slides, you mentioned Python. Is Python the only language that can be used to write code in them?
So the Jupyter Lab currently has Python kernels, and we also have our studio with R, and we are in the process of adding more apps into the on-demand interface. So we will be supporting VS Code server as well, which I think enables you to run any language that's supported by VS Code, and can be extended as well. And the environment enables us to add apps that may be popularly requested apps into the system as well. So, yeah.
Alex asks, how much more expensive is it to compute on the Research Developer Cloud compared to the Slurm core hours cost roughly? So I guess he's probably talking about the dollar values here.
Yeah, so we actually just gone live with our pricing page. I haven't, it is actually shared on the linked slides, the pricing page, but it is the compute hours are actually cheaper on the Research Developer Cloud. However, it is not optimized for parallelism and all the high throughput that our HPC offers. So it is actually cheaper, but not really suitable for high performance. So even if the number of cores might be same and the dollar value might be lower, you will see higher output in the NZRSE HPC.
Mm-hmm. Thanks. And one last question from Maxime. Is there any API to access the HPC from the cloud platform? For example, FiRack REST or DAS Gateway or maybe Globus Compute? And if so, any documented example to play with?
Right. That is a commonly mentioned interest point. As we do the NZRSE migration, I think that will become a lot easier. Right now, we have the Research Developer Cloud in Auckland and HPC in Niwa, Wellington. So we are migrating to the same site, and we do have Globus compute-based interface use cases, but we don't really have it in a sort of like a publicly documented level. I believe there are some consultancy projects and things like that that utilizes it. So I think that's definitely upcoming. So the transition would be much more seamless.
Mm-hmm. Great. Thanks, Jun. All right. We're at the end of the session now, so I'd like to very warmly thank both our speakers again. Great job, and enjoy your lunch, and we'll see you back at 1 p.m., I believe. Thank you very much.
Thank you.